Hello everyone, welcome back. Today is the last part of the section Subgrade soil and pavement materials. In this section we are going to talk about the mechanical properties of pavement materials, and I think this is also the most important section. At the beginning, again, I would like to introduce or let you guys to take a look at the typical structure of a pavement, surface, base, subbase, and subgrade. And this is for the asphalt pavement. For the concrete pavement, it could be a little different. The contents of this class, we are going to talk about the mechanical properties of the unbound granular materials, inorganic binder stabilized materials, asphalt stabilized materials, asphalt mixtures, concrete mixtures, and recycled materials. First, about the unbound granular materials. We know that for the unbound granular materials, there is no powerful binder material side, so there is no tensile strength, but the shear strength, we have it. Where does the shear strength come from? It can be from several aspects. For example, it can be from the sliding friction of aggregate surface, can be from the aggregate interlock, and it can also from the resistance of volume expansion during the shearing, and also can be the resistance due to the particle reorganization. And again, there is no tensile strength. So how about the mechanical models of unbound granular materials? Generally, it can be composed of two parts. The first is a spring. What is a spring? That means the deformation should be elastic. That is, if we apply a load, we have a deformation. If we remove the load, the deformation comes back. So we call it elastic deformation. And it can also include the slipper. Slipper means that the particle reorganization. If we have a deformation, the deformation will not come back. That is the plastic deformation. About the inorganic binder stabilized materials, we have some basic characteristics. For example, the most important, the strength and the modulus. Generally, these two parameters, they increase with the curing time. So at the bottom, we can see that there are two pictures about the strength and the modulus increase with curing time. You can see that from the day 1 to the day 90, it will continuously increase. And after that, we can see that the strength or modulus increase will be slower. And we also need the design curing time when we really make the design of the inorganic binders. For example, for the cement stabilized materials, usually we use 90 days. And for the lime or lime fly ash stabilized materials, we can use 180 days. So this means the design curing time of the inorganic binder stabilized materials, it really depends on the types of the binder. We know that for the IBSM, it has some strength, both the tensile strength and the shearing strength. So where does the strength formation, or where does the strength come from? Generally, it can come from several aspects. And for different binders, they may have different mechanisms actually. For example, we list the lime stabilized material and the cement stabilized material here. For example, for the lime, these mechanisms could be the ion exchange, the crystallization, the carbonation. And for the cement stabilized, this can be the cement hydration, ion exchange, chemical excitation, and carbonation. And on the right, you can see that this is a very complex figure. It shows you those detailed mechanisms, and you can also see some equations, formulas. If you have more interest, you can read them very carefully. And of course, these knowledge, they are also introduced in the class of road materials. And for the properties considered in pavement engineering, because we know that they have some mechanical properties. So what are those main properties we need to consider in the pavement engineering? Here we list some of them. First, the strength. We have the compressive strength, the tensile strength, and the fractural strength. All of them are important. And also the modulus, the receiving modulus, tensile modulus, fractural modulus, and the fatigue performance. Fatigue performance is very, very important because, as we mentioned before, the inorganic brine stabilized material is widely used in China, and they are also the main base type in China's highway system. And one design parameter is based on the fatigue performance of the IBSM. And about the dry shrinkage property, we know that for this type of material, during the curing time, they will shrinkage. We call it a dry shrinkage. So the dry shrinkage property will affect the early age cracking. Sometimes we call it shrinkage cracking. And also the thermal contraction. Thermal contraction is also a property of the inorganic brine stabilized material. All of these properties or mechanical properties we need to consider. Yeah. And on this slide, we also show two pictures. The first is about the fatigue performance of this type of material. And on the right, we show the picture of the construction of this type of material. How about the asphalt mixture? What's the strength for the asphalt mixture? And on this slide, we show that the asphalt mixture, it is made of mineral aggregates and the asphalt binders, right? And also air voids. So the strengths, generally they come from the interlock and the internal friction of aggregates, and also come from the cohesion of asphalt, and also very importantly from the adhesion between the asphalt and the aggregate. The viscoelastic property is one of the distinct or unique property for asphalt mixtures. So what is the viscoelastic property? We know that the elastic material, for example, concrete, it is generally an elastic material. And a viscous, for example, we know that the water, that is a viscous material. But what is a viscoelastic material? Generally, this picture can show this. For example, on the left, that is, if the asphalt mixture is subjected to a dynamic and a cyclic loading, we can see that. The red line, that is the stress response curve, and the green, that is the strain response curve. We can see very clearly that the strain lags behind the stress. So this is very, very important and a unique property for the viscoelastic material. So what does this mean? It means that if we apply a load, at the beginning there is no response for the deformation, and after a while we have a deformation. And on the right, we also show the typical curves of the creep test and the creep and the recovery. For the creep and the recovery, we can see that if we apply a load for a while, after that, if we remove the load, we can see some of the deformation has been recovered, but some others, they are not. And the viscoelastic property, again, it is very important for asphalt mixtures. And what are those properties need to be considered in pavement engineering again? So generally, we have the permanent deformation resistance and the thermal cracking resistance. For the permanent deformation resistance, it will affect the rotting performance. If you drive or sometimes you walk on the road, you can see that they are rotting on the road. So that is a permanent deformation resistance. And the thermal cracking resistance, this is very common or very important in those cold regions. For example, the northern part of China. In the winter time, you can see the thermal cracking. It is generally transverse cracking. So sometimes we also call the thermal cracking as transverse cracking. And some other properties, for example, the tensile strength, it is of course very important, right? It is the main strength, and also the fatigue cracking resistance. Because if we apply the asphalt mixture on the road, the asphalt pavement is under repeated loading of traffic. So we need to evaluate the fatigue performance. And also the last one is the moisture damage resistance. What is the moisture damage? Generally, what we can see on the road is that the raveling and also those potholes, so all of these from the moisture damage. We also need to test the moisture damage. So we can see all these 5 mechanical properties or performance we need to take account in the asphalt mixture design. So for those detailed test methods, we can refer to those standard specifications from, for example, ASHTO and China's specification. For the asphalt stabilized materials, we have mentioned before, for the asphalt stabilized materials, it is different from the asphalt mixtures, and it is usually applied for the base course. So compared to the asphalt mixture, what's the difference? It has better shear resistance due to the larger size. We mentioned that. Generally, the asphalt stabilized materials has a larger size than the asphalt mixture. And usually we use unmodified asphalt because it is used on the base. So we do not need that better performance asphalt. And also lower asphalt amount. And a lower strength, weak fatigue resistance, because we have lower amount of asphalt or lower bind, so the fatigue resistance is usually weaker. So how about it compared to the unbound granular materials? Generally, it has a stronger in strength. So the strength can be as high as 3 times. And it can also save the excavation cost. For the concrete materials, those properties we need to consider in pavement engineering, 2 important of them, that is the tensile strength and the fractural strength. And we can also use different test methods. For example, for the tensile strength, we can use the indirect tensile strength test. And for the fractural strength, we can use the beam fractural bending test. And some impact factors in pavement can affect the properties. For example, the water content. If we change the water content, the strength may change. Also the temperature change and the temperature gradient. Oh, this is very important, especially for the concrete pavement. We know that in the daytime and in the nighttime, we may have different temperature gradients between the surface and the bottom for the concrete slab. And also the traffic loading, of course, it will result in crackings and fatigues. Now I think it's time to have a summary of some key parameters we have introduced so far. For example, different material types. We have unbound mix, IBSM, ATB, asphalt mixtures, and concrete. For the unbound mix, we have the shear strength, the CBR, MR, and the IBSM. We have the tensile strength, the fatigue, and we can also have some other parameters, for example, shrinkage. As for the treated base, what are important, that is shear or direct and a bending strength, and also very importantly, the fatigue performance. For the asphalt mixtures, we have the shear, direct or indirect tension, and we also have the bending beam. And we also have the TSR for the moisture damage resistance. For the concrete, we have the direct, indirect tension. We may also have the fractural. Okay, I think that's it for this section, and thanks again for your attention. That's it for the subgrade soils and pavement materials. Thank you.